brand new from the edge of the solar system. The clearest images of 3I/Atlas have just landed, and nothing about them makes sense. It's officially called a comet, 2025 N1 Atlas. But there's no familiar tail, just a faint, sunward anti-tail that defies every standard model. Even the object's shape looks more like an oval shield than any comet we know, and the experts behind the astronomer's telegram number 17,445 are openly cautious about what, if anything, we're really seeing. When honest science admits it has no answers, are we looking at a natural visitor or something built? These are the stakes as we break down 3I/Atlas, clearest images released so far. Every claim about 3I/Atlas, no matter how exciting, faces a simple test. Can it be independently confirmed from more than one source? That's the yardstick used by working astronomers and the best skeptical observers alike. With images this faint and ambiguous, the two-source rule is more than just a formality. It's a lifeline against wishful thinking and hasty conclusions. When the clearest images arrived, the first task wasn't to decode the mystery, but to check. Do different telescopes, different teams, see the same thing? The answer so far is yes on the big picture. An object with a strange, shield-like outline, lacking the classic tail. But the finer details? Still up for debate. There's a temptation, especially in moments like this, to let the mind fill in the gaps with what it wants to see. For years now, the outline of 3I/Atlas in stacked images has looked less like the round, fuzzy ball of a typical comet and more like a stretched oval or a piece of armor. The new images don't settle the question, but they do nudge it forward. The core appears elongated, not perfectly round. The edges blur into the background, making it hard to say where the object ends and the surrounding coma begins. Is this a real feature, or just an illusion from how the images are processed? Until the raw FITS files from multiple observatories all tell the same story, shape remains a hypothesis, not a fact. Resolution limits are a stubborn barrier. Even with a 2-meter telescope, the best we get is a handful of pixels across the brightest part. Any claim about precise dimensions or contours is, at best, an educated guess. The actual size might be a few hundred meters, or several kilometers. No one can say for sure. What matters is that the outline, whatever it is, doesn't fit the playbook for known comets. Honest science means holding that uncertainty in the open, not hiding it behind confident language. If the shield-like form holds up under more scrutiny, it will be because the evidence survives every skeptical test, not because it fits a favorite theory. The best we can do now is mark the hypothesis, watch for repeatable confirmation, and resist the urge to declare the mystery solved. On October 15, 2025, the astronomer's telegram number 17,445 delivered a short, clinical summary that sent ripples through the comet-watching world. Using the 2-meter twin telescope, observers reported a faint jet and a striking anti-tail on 3I/Atlas. These aren't just labels, they're physical clues. A jet means a narrow stream of material, usually gas or dust, shooting away from the object. An anti-tail is even stranger. It points toward the sun, not away from it. That's the opposite of what most people expect when they picture a comet. The classic tail, blown back by solar radiation, is missing. Instead, a narrow spike leans sunward, defying textbook diagrams. The telegram's language is careful. It describes the anti-tail as a real, persistent structure, not just a trick of perspective. Standard comet models explain anti-tails as projection effects, large grains lagging behind in the orbital plane, briefly lined up so they seem to point forward. But in this case, both the jet and anti-tail are visible together, and the anti-tail's brightness and duration are hard to write off as mere geometry. Photometry and polarimetry back this up. The anti-tail remains nearly as bright as the main coma, and its polarization suggests a dominance of larger dust grains, not the fine mist seen in ordinary comet tails. To match what's seen, dust dynamics models have to invoke unusually big grains, hundreds of microns across, ejected slowly and biased in the sunward direction. Simulations show that only slow, heavy particles survive long enough to build a physical anti-tail like this. It's a rare configuration, and the persistence of the feature over weeks, confirmed by Hubble, Gemini, and ground-based teams, rules out a fleeting illusion. The Telegram's straightforward bulletin becomes a puzzle piece. The morphology of 3I/Atlas doesn't just stretch comet definitions. It demands new explanations for how material escapes and lingers in interstellar visitors. Every confirmed feature, jet, anti-tail, lack of a normal tail, raises more questions about what this object really is. The official name stamped on every press release is 2025 N1 Atlas, a label chosen by the International Astronomical Union's committee in line with their rules for active objects. That designation, comet, not just interstellar visitor, carries weight. It signals to the world that, whatever its quirks, this is supposed to be a familiar kind of body, icy, volatile-rich, and behaving as most comets do when heated by the sun. But the evidence refuses to cooperate. Avi Loeb, who has spent years challenging the boundaries of what counts as a natural explanation, put it bluntly, it doesn't look like a typical comet. That frustration is growing among researchers who have combed through the latest data. The water vapor loss rate, measured at nearly 1 kilogram per second by NASA's Swift Observatory, matches what you'd expect from a lively comet. But the rest of the picture is out of sync. There's no broad solar wind-blown tail. The anti-tail, persistent and bright, points toward the sun. And the core's shape, oval, shield-like, never cleanly round, remains stubbornly ambiguous in every stacked image. Even the composition is under a cloud. Hints of nickel and iron in the spectrum, if confirmed, would set 3I Atlas apart from every comet cataloged so far. Yet no peer-reviewed paper or public data release has nailed down those metallic fingerprints. Every claim is provisional, every anomaly a challenge to the rules that define what a comet is supposed to be. For now, the label stands, but as the list of contradictions grows, the question behind the name only gets louder. Every pixel in the latest 3I/Atlas images comes with a chain of custody. It starts with raw FITS files, those digital originals that record the sky exactly as the telescope saw it, before any background subtraction or cosmetic touch-up. The moment an image goes from raw to processed, choices pile up: which frames to keep, how to align them, what cosmic rays or hot pixels to mask, which stacking algorithm to run. Each step can sharpen real features or introduce ghosts that never existed in the sky. That's why the demand for open, unaltered FITS files is so loud right now. Without them, no one outside the original team can rerun the analysis and check if that shield-like outline or those mysterious dots near the core are genuine, or just artifacts from a particular script or parameter tweak. Some of the oddities, like the scattered points near the main object, may be nothing more than the fingerprint of the stacking process. When images are aligned on the comet, background stars can leave dotted trails or patches, especially if the tracking isn't perfect or the field is crowded. Switch to star track stacking, and the comet itself becomes a streak, while the stars snap into focus. Only by comparing both methods and repeating the process with different pipelines can teams be sure which features persist and which vanish. That's the difference between a discovery and a mirage. The path forward is clear, if not easy. Release the raw data, the calibration frames, and the reduction logs. Let independent groups rerun the stacks, test for artifacts, and publish their scripts and results. For every hypothesis, whether it's a shield-shaped nucleus, a physical anti-tail, or something more exotic, the next step is to spell out a prediction that can be checked. If the anti-tail is real, it should survive in new images taken as 3I/Atlas rounds the Sun. If the core's shape is genuine, it should appear in stacks from at least 3 independent observatories using different instruments and algorithms. If a claim can't be tested or repeated, it doesn't belong in the scientific record. The coming months will bring more data, more scrutiny, and, if the process holds, answers that everyone can check for themselves. While some speculate about exotic origins, current evidence does not confirm or exclude any natural or artificial hypothesis. The scientific record shows only this: 3I/Atlas does not fit standard categories, and its true nature remains undetermined. Until further data is released, the mystery stands, reminding us that honest science always leaves room for the unknown.